Randall, and we are doing our project on golf. First, we found the elasticity of the golf ball. This is important because the warmer the golf ball, the more elasticity the golf ball has, and the farther the golf ball travels. So golfers in cold weather have to increase their golf distance in order to keep their golf warm. And so this is the equation for the elasticity. And what we need to know here, our inputs are the final and initial velocities for both the golf ball and the club head. And when I input this into Matlab using different values, this is what I got. Okay, so which means that when I changed my values of velocity and I got a larger elasticity, that wasn't good. It's better for the distance of the ball. And then the second function is using the same elasticity equation. Since we already know the elasticity of the golf ball, I use I rearrange the equation in order to find out for the final velocity of the club head if I know all my other values. And in this case, when I ran this into Matlab, this is what I got: 50 meters per second, and then 58 for meters per second for the second one. I then found a velocity and distance relationship using a distance equals horizontal velocity times time, and I gave different values to horizontal velocity and set the time to 10 seconds, and then I plotted velocity versus distance, and what I got was a linear relationship between velocity and distance. However, this does not mean that the farther the ball travels, the more velocity it has. It's all the opposite. The farther it travels, of course, it loses velocity. But what it means is that the initial velocity. So if you hit the ball at a larger initial velocity, your ball will travel farther than if you hit it with a lower initial horizontal velocity. So that's what it means. And then I also use matrices for scores. So I have 4 players, and each player played 9 rounds, but this is a 1, 2 through 4 round. And this here, I arranged in a matrix all the players' scores. So for the first player, the scores from rounds 1 to 4 are on the first row. For the second player, second row, etc. And so on. And then here for rounds 5 to 9, also arranged. And then let's say if I want to know, I want to know more values. Like I want to put my 2 matrices together. So let's say for the first one, I said round 1 plus round 5. For the first player on the first row, first column, and then on the second column, first row, first player, it's like round 2 plus round 6, and I did that for all the players. And then let's say I want to know all the total scores for each player. I have to transpose that because Matlab only adds columns and not rows. So I transpose that, and then that's how I figured the scores for each player. And then I also created a script file which is for choosing clubs, and it's intended to help players choose clubs based on their expertise. And so in Matlab, you have to, if you're a beginner, you enter 1, if intermediate, enter 2, and if advanced, you enter 3. And this is what my script file looks like. And then just to see that it works, when I run this in Matlab, which my file name is choosing clubs, and then I say enter, and then I say, well, enter golf expertise. So let's say I'm a beginner, and that's what I get: a 5 wood, and then titanium driver, etc. And then if I say I am, let's say, an advanced, look at, like, I get less values, less clubs, because I'm supposed to already use the best clubs around. And let's say I say 5. And then it says error, unknown clubs, you need to define your expertise. So that's what happens when you don't input 1, 2, or 3. So going back to this, and then what Randall did here was he first converted temperatures from Celsius into Kelvin. So by it using 70 degrees Celsius, and that's what he got. And then the second function file was finding the density under standard conditions. And he used different values. The set value was the R constant, which is the R gas constant, which is 286.9 joules over kilograms times Kelvin. And then inputting different values for the pressure and the temperature, then that's in MATLAB, that's what he got. And then he also did the finding density under real world conditions. So here, under real world conditions, we have to take into account the gas pressure, the gas constant for water vapor, and the gas constant for dry air. And here, R constant again is the constant for dry air, and the R constant for water vapor. And inputting pressure for dry air as our input, and pressure for water vapor, as well as temperature in MATLAB. These are the answers. These are the answers that he got in kilograms over meter cubed. And then he did another one for the finding the cross-sectional area of the golf ball. Since it's a circle, well, we use the area for a circle, and our input here it's the radius, and we followed the U.S. According to the U.S. Golf Association, your ball can't be less than the diameter of the ball can't be less than 42.67 millimeters, but we converted the radius into meters, and then this is the answer that we got in meters squared. And then finding the lift force. The lift force is important. We want more lift force when we are first going to hit the ball, because we want it to travel a farther distance. But let's say if we're in the green, then we want a less lift force, probably because we want a shorter distance, and that's the importance of this. So inputting density, area, and velocity of the golf ball, and knowing the lift coefficient, which according to the U.S. Golf Association has to be within a range, and inputting that's what we got in units because it's the force. We also did the same for the drag force of a golf ball, using the same inputs as with the lift force, but in this case, the drag coefficient is different because also it has to be within a range. And that's what we got when we inputted those values into MATLAB in newtons. And then the drag force trajectory also, this is important. This just calculates the trajectory of the drag and the x, y, and z direction. So our input is velocity in the x, y, and z direction, and also the coefficient of drag. That's what we need to know. And so here, when we inputted those values, it says the trajectory due to air resistance of the golf ball is, and then -20 or 0.25 in kilograms over meters times second. And then the last thing was a script file, which is intended to help people find a golf course near their area in Tucson. And here it asks you to enter where you want to find a golf course at. So 1 equals south, 2 if you're on the east side, and this is the script file, etc. So to test the script file, let's see. So the name of the script file is called choosing golf course, and then it says, so enter the area where you would like to find the golf course at. So let's say I'm at the north side and I want to say 4. So it says Oro Valley Country Club, and it even gives you the address, which is pretty nice because you can just go find it. And then now let's say I'm at the west. Okay, well it says Star Pass Country Club and Spa. Ooh, nice. So it gives you the address, which is pretty nice for people just going out of work and people that want to actually, Now let's say if I am at the 7th, so southwest, it says none, under construction. So out of all the golf courses, that's the one that's under construction. So that's our MATLAB video. We had a blast doing it. Thank you, Dr. Waller. Thank you.